Here I'm going to give you a few key points about area V4, which is part of the ventral stream. To get context, remember that area V1, which is this area here, is the primary visual cortex. V1 sends information towards V4, which is roughly in this area here. What's special about V4? It's on its way towards this stream here, and the way we can figure out what's important about V4 is to think about its response properties. So first of all, one thing you notice, as you recall from neurons in V4, is that they have large receptive fields. They're responsive to quite large areas. Each cell is responsive to light in quite large areas of the retinal map. The second thing is that they're sensitive to orientation. So that means, for example, for a line in one angle, you might get a small response, but then if you move it to a slightly different orientation, you get a much bigger response in the neuron. So they're responsive to orientation, and they're also responsive to colour. So notice that I say here colour and not wavelength. Colour is different from wavelength. Wavelength is a physical property. Colour is much more to do with our perception of the qualities of an object. So that suggests, these things together suggest that V4 is working out one of the first steps in shape and colour perception. So what I mean by that, let's think about some of the odd properties of colour just for a moment. So if you remember, just a step back, neurons in V1 are sensitive to wavelength, and that's the same in V2 as well, whereas neurons now in the next level up, which is V4, are sensitive to colour. What's the difference? Well, I'm going to take you to a website now. This blog spot here illustrates it quite perfectly. So you'll notice in this diagram at the top, you'll see a colour cube, and we've got the bottom right, we have a bluish subsection, and just above it, it looks red. So let's look at that a bit more closely. So at the bottom corner, the arrows, they look like different colours, but look what happens when you actually grey out everything except those two areas. They're actually exactly the same colour. Sorry, the same wavelength, the same mixture of ink, if you like. What's happened is that when your visual system takes in the whole picture, it makes corrections for difference in the colouring in terms of the wavelength, and works out that given the context, given the lighting conditions and everything around it, that although the wavelength, as in this picture, is the same in the two blocks, so the two corners, bottom right corner and top right corner, the wavelength is the same. So a V1 neuron here would respond the same as a V1 neuron here. But then when you take into account the surrounding colours and the surrounding lighting, you can work out that even though the wavelength here is the same, the colour must have been different. And that's what these cells in V4 have done. They've taken information from various parts of the whole visual cortex and then worked out that the wavelength information in V1 now has been turned into colour information in V4. So that's what V4 has done. It's worked out shape and colour.